two events A and B are said to be statistically independent if P of A given B equals P of A. You have come a long way in learning probability, but your training is incomplete without learning about the most famous master of our school. His name is Master Bayes. With his teachings, he has laid the foundations of data science. Probably the most famous theorem in the field of probability is the Bayes Theorem. It deals with a particular case where you have several mutually exclusive and exhaustive events, and another particular event which has some dependence on each of them. Let's explain this with a Venn diagram. Let us say we have n mutually exclusive events A1, A2, A3 up to An. These events have another property, i.e., together they cover the entire sample space. In other words, they are exhaustive. So I have represented them with non-overlapping rectangles, which together make the sample space. Now, there is an event B which has some intersection with all of these events. It is not necessary that there must be overlap with every event. Some intersections can be zero. Let us suppose that P of B given A1, P of B given A2, and so on, P of B given An are known. We also know the individual probabilities of the exclusive events, P of A1, P of B2 up to P of An. Now suppose we are given that the event B has already happened. Can we now calculate the conditional probability of P of A1 given B, P of A2 given B, and so on? If you notice, B has overlaps with each of the other events. So we can say that the area under B is just the sum of these intersecting regions. So P of B equals P of A1 intersection B plus P of A2 intersection B plus all the way plus P of An intersection B. Remember, by multiplication law, P of B equals P of B given A1 into P of A1 plus P of B given A2 into P of A2 plus P of B given An into P of An. From the same multiplication law, P of A1 intersection B equals P of A1 given B into P of B. That's also equal to P of B given A1 into P of A1. So P of A1 given B equals P of B given A1 into P of A1 by P of B. By just plugging the formula of P of B that we just saw before, P of B given A1 into P of A1 divided by P of B given A1 into P of A1 plus P of B given A2 into P of A2 plus so on P of B given An into P of An. We are already given all the numbers on the right hand side, so we can calculate the number on the left hand side. And that's the Bayes theorem. Now let's see if we can solve some problems using this Bayes theorem. Suppose in a university, 75% of the students live on campus and 25% live off campus. Of those living on campus, 50% own a vehicle. Of those living off campus, 80% own a vehicle. You are given a student who owns a vehicle. What is the probability that he lives on campus? So event A1 equals student lives on campus. So P of A1 equals 0.75. Event A2 equals student live off campus. So P of A2 equals 0.25. Also, event B equals student owning a vehicle. So P of B given A1 equals 0.5 and P of B given A2 equals 0.8. You are asked P of A given B. From the Bayes theorem, we know that this is P of B given A1 into P of A1 by P of B given A1 into P of A1 plus P of B given A2 into P of A2. that equals 0.5 into 0.75 divided by 0.5 into 0.75 plus 0.8 into 0.25. Your calculator will tell you that this comes out to be 0.6522. Suppose there are 3 chests and each chest has 2 drawers. One of the chests has a gold coin in each drawer. One of the other chests has a gold coin in one drawer and a silver coin in another. And the remaining chest has silver coin in each of the drawers. You pick one of the chests at random and then you open one of the drawers and you find a gold coin. What is the probability that the chest contains a gold coin in the other drawer? Now you might be thinking, well, there are 2 chests that contain gold coins since the third chest has only silver coins. So the probability must be 1 by 2. Well, let's see. Let event A1 be choosing the chest with both the coins gold, A2 be 1 gold and 1 silver, and A3 equals choosing the chest with both coins silver. If you are choosing at random, the probability of picking any one of these chests is 1 by 3, so P of A1 equals P of A2 equals P of A3 equals 1 by 3. Let B be the event that a gold coin is found on opening a drawer from a chest. If the chosen chest is A1, then P of B given A1 equals 1, since it is guaranteed to be a gold coin. P of B given A2 equals 1 by 2, since one of the coins is silver, and P of B given A3 equals 0, since both the coins are silver. We are given that B has already happened. Now what is the probability that the chosen chest was A1? P of A1 given B, from Bayes theorem, it is P of B given A1 into P of A1 by P of B given A1 into P of A1 plus P of B given A2 into P of A2 plus P of B given A3 into P of A3. That's 1 into 1 by 3 divided by 1 into 1 by 3 plus half into 1 by 3 plus 0 into 1 by 3. This turns out to be 2 by 3. Your intuition said it would be 1 by 2. Remember, I told you that intuition can get you in trouble on the streets of data science. So intuition can get you in trouble on the streets of data science. See, I did tell you that. We are one more step closer to the destination, but our saga continues. Want to continue the journey? Then subscribe and like. You must practice hard if you want to learn how to defeat this foe. It is called word problems.